Welcome to Cloud Training for Enthusiasts. My name is Usatome Patrick Aigbogun, and today we are still in the process of DevOps. This is February session 2023. It has been a very interesting journey, and thank God we are here. We're almost close to rounding up this session. We are doing the most important and most interesting part of DevOps. As a matter of fact, this is where DevOps 2 actually started from. When you hear the word DevOps, this is one of the major handshake between the operation and the developers, Dockerization. So Dockerization is more than just creating a container. It's more also about collaborating with the developers to know how you can bring the application into a containerized system that can be easy to operate, easy to deploy. So Docker is around in this system, in this whole pipeline. Docker is around under development. The next is integration. Is within this integration process. Is within the integration process because after you've developed, you have to integrate it. Process of integration. Talking about pull requests. Talking about Dockerization, containerization. You can also test. This testing can come under development. This testing can also come after you Dockerized it. Then monitoring. Although they didn't, I don't think they put this thing in the form of in a simple line. Monitoring, feedback, deployment, operation. Because after you test, you check if the artifact is running, then you deploy to your infrastructure, from infrastructure, you deploy to the complete operation, the operation team, see how it works, and give feedback. When the feedback comes from the operation team, talking about the customer care, the technical support, and the people that are facing the customers, you understand? They give you feedback, then you take the feedback, take it back to the development improve, which is called continuous improvement, also known as feature build and feature upgrade. You build a feature based on what the customer wants, integrate, you test, you deploy, like that. You understand? This is the feedback loop. So Dockerization is around here. Deployments, development and everything, infrastructure is what lies behind all of them. So infrastructure comes first in the circle of pipeline. That's why we must talk about infrastructure. That's why we took more time to talk about infrastructure, because infrastructure, you may not say infrastructure yet, but infrastructure is what all these things are sitting on. And after infrastructure takes place, the next thing is development, which is talking about code-based management like Git, GitHub, and Bitbucket. Then from there, you talk about configuration management, in terms of this infrastructure, how are you going to make sure that this infrastructure delivers the automation process? That's what we talked about Ansible last time, Terraform, so it can be easy for you to deploy your infrastructure. Now, when infrastructure is being deployed, right, you need to understand how that code can become easy to deploy. So when the code, because I'm not talking about code management, because I don't write code, but we talk about code management, which enable you to work with the developers. Then how the developers have successfully done that, the next you do is this integration. This is why we are here. So integration is the major part of DevOps system and development lifecycle, software development lifecycle. You can see it's still under here. Under this is what takes place in integration. You plan, you build, you continuously deploy, you operate, you understand? So we are still in this process of building. So we are taking these tools under the same building, use applications to build Git, GitHub, GitLab, Bitbucket, which we have treated this. Now we're here now. We are going to take just one tools here. We'll take this for building. Then for integration, we're also going to take Dex, Kubernetes, take this too. Then after we take this too, we'll do Jenkins. Then after do Jenkins, then which other thing? Deployment. We already talked about most of the deployment, Kubernetes. We're still going to do Kubernetes and Docker. Then, so this Docker here, talking about how to convert the code into Dockerization, What is Docker here talks about? To take that Docker into a Docker engine to use or a Kubernetes engine to use. Most of them are the same. So we're not talking about operation. We have already talked about operation. We've done Jira, right? We've done Jira. Then feedback is regular feedback. You talked about Slack and Zoom. We have been using Zoom. So, and Play Store or our Apple Store. This is where you get your feedback from the customer. So this is why this part is very important, because you can see Docker is here for continuous building, and Docker is also here for continuous deployment. So this is why we're here. So please take note, our class today and tomorrow, if we're able to finish Docker today and tomorrow, we do Jenkins. Then after I finish Jenkins, no, we do Docker, we do Kubernetes, then we do Jenkins. Then after Jenkins, then we do Jenkins, then we do the complete pipe. We all run a simple pipeline, putting all these tools we have done together, then we are done with our class. So that is the reason why we're going to have a class on Tuesday, Wednesday, and Thursday at the same time. If they're going to be changed, I will let you know, but we're going to have this 3 class before we round up our class next week. And thank you for those of us that have stayed this long. I know it's not easy, but thank you. And for those of us that have missed 1 or 2 labs, don't feel bad. You can still catch up with the labs, but just try and finish this class. Because by the time you finish it, you may end up, even going back to the full details. You may end up still catching up, you understand? So that is for this class. So in some minute time now, we're going to start Docker. Thank you. Okay, just to refresh our mind, what Docker really is. Docker is an application that enable you to ship. It's a system software that enable you to ship application instead of just installing every time, installing the underlying infrastructure every time. So it enable you to just pick up application that has a similar framework, a similar architectural framework, a similar hardware framework, like you just ship them together so that you just install the Docker engine, which is going to serve as a bridge between the application and the framework. Then you now put the Docker on top. So instead of installing, remember last time we were making an instance that, I think this was the instance. No, okay, this was the instance. Okay, we're making an instance that instead of putting an application at the same time, after the application, we start loading maybe Microsoft, you want to install an Office suite in your system. If you are using a regular RPM, what you just do, you install application. Then after you install the application, the next thing, the application will come with its own payloader, with its own Linux, if it's your Linux system, with its own Linux architecture framework, and other things you require for the application to run. Sometimes it can come as high as 700 megabytes. So you understand me? Meanwhile, the application inside that 700 megabytes is just like 50 megabytes or maximum 100 megabytes. So the remaining 600 megabytes is for the application to run in that framework. So now imagine now you want to install 20 application, maybe 20 word processor into that system. So what it means is that that space is going to carry that 20. Imagine they have not yet updated, just at a static state. So you're going to be running like 20 times 7 times 700. Let's say 14 gig. Abi, almost 14 gig now. 700 times, okay, that's 1.4 gig, right? 10 will be 7 gig, right? Yes, so 10 will be 7 gig. Then 20 will be 14 gig. So imagine installing 14 gig because you want to run 20 applications. And when those 20 applications now run updates, sometimes it can increase to up to like 15 gig. So instead of doing that, you can just install only the Docker of the application, the Docker framework of the application. You understand? This is just the illustration. So imagine you just install the Docker framework of the application. Then after installing the Docker framework of the application, let's assume this is the Docker framework of the application. Then what you just need to do is just to pick up that Microsoft, that Office suite, and be putting the 100 applications. So at the end of the day, you can use one system, you can install that same 20 application of that word on that word processor, 20 of it. So instead of doing 14 gig, you will now be using 2 gig. So imagine if you come in, for example, you go into a company that are using that kind of system, and you not tell them and you optimize the application, and you the same application that they'll be running with 20 gig, with a 14 gig, you're able to optimize it to 2 gig. You see the optimization. That's more than 20,000%. You understand? So meaning the system will now take more application and still deliver the same level, the same property, the same efficiency. Because when the application goes down, it goes down. It doesn't matter if it's 20 gig that the application is running on. You understand? So this is where Docker comes in. So your Docker engine will carry the framework of the operating system. That is why you cannot install a Docker engine for Windows in Linux, or install Docker engine for Linux on Windows. But if you are running a Windows Linux system, you install a Docker engine of the Linux system, the application you'll be running on that framework is going to be Linux system, Linux application. That is one of the advantage of a Docker engine. So now the other thing, that interesting thing about the Docker engine is this. The Docker engine also comes like a normal, it comes like a VM. So it has its own firewalls, also known as ports. It has its own networking system inside. So it's just like a VM in form of an application. That is why it's called a container. So meaning the Docker will bring all these applications that you have, it will zip them into a small place, partition or location. And that application can work within that same location, inside that same particular storage, that same particular unit. So that unit is what we call container. You understand me? Inside the engine. So the application will be there, the virtual will be put, then you load the image. The image means the application you want to run. So this engine will now spin up an application that looks like a virtual machine and zip it together, and put that your application you want to run inside it with a variation. You understand me? So for example, if this is a Linux on Ubuntu, so I'll put, when this pod wants to run, this pod will just set up a container. That container will have a little framework of Ubuntu inside, because that little framework will be what will enable it to communicate with this virtual machine. You understand? Then after zipping it, then you will now explain how you want the application to run inside this container. And you understand me? The document that you use to explain how this container runs and how it will work is called a Docker file. You understand me? It's called a Docker file. So you can run either Docker apply or Docker compose or Docker run. Most times Docker run or Docker compose. Docker run means start the engine. While Docker compose means put all this engine together and connect them together. So every pod will have its own ports. That's why when you are binding a port, this one, it's like we all know what is the port for Nginx. Default port for Nginx is what? Port 80, right?
80.
Port 80. The regular is actually port 80. But just that sometimes we don't like our application to be running floating. So we cannot just put it in port 80. When we say port 80, you're talking about 80, it could be 8080, could be 188011. You can just put any different. But port 80 is the default, which is also the default for web. All our website, all HTTP is port 80. So while all HTTPS is for port 443. That does not mean that you cannot give your application in different 44. You can put it in 4445, 446. You understand? Just to tweak it so that somebody cannot just go to the internet directly and hit your application. You understand? So that your application can have some leverage. You can put it port 8080, port 1990. For example, if you want to deploy this application now, or Prometheus most times is port 1990, but it's still the same within that framework. So every application will have their own port. So this port is what you will now bind to your VM. For example, if this application is running port 80, or let's say this application is running at, maybe it's a database application, is running at port 1005. So if it's running at port 1005, that is where this application, meaning this port that you have, you open up a little space called port 1005. That is meaning of open, that is meaning of port, meaning you just dig a little hole so that the application inside can leak out through there.
Parts.
Hello?
Yeah, I said like parts. Parts
Yeah.
for.
So that is what it is. So what it means is that you just, a port, when you say a port, open a port, meaning you just expose that part so that people can communicate to the application, because at default, everything is locked. So when it says a port is open, meaning you have allowed people to communicate to the application through that port. Now, despite the container is open, it does not mean that people can reach it, because why? The container is inside a server or inside a system. So you need to bind this port with a port of the server. So that's why when you are running a Docker, you bind Docker to a port. Sometimes you don't even need to bind it out. You can bind this Docker to this Docker, to this Docker. Then the only way you can communicate to this Docker is through this Docker. So that means this is the Docker you're going to bind to the port. But this 3 Docker must communicate within it. So just consider it like a VPC. All the subnets in the VPC are private. They can communicate to themselves when you bind them. Though that does not mean that people can reach it from the outside unless you attach an Ethernet gateway to it. Please, can we just mute, please? Help us. Okay, so that is just the difference between a Docker and a regular VM. A Docker is just that in a VM, which is a regular virtual machine, you can put an application called Docker Engine on top. So with that Docker Engine, which will carry underlying framework that an application can use to run independently. So whenever you are deploying an application, you just put a little portion of that operating system, are you getting me, and the application. So an application is called an image. Already designed application ready to test is called an image. You understand? So for it to be called an image, you have to build that application to be a Docker image. So to build an application from regular application, maybe a regular source code to become an image, that means you have to write a file that can communicate with that your application, so that whenever that, for example, PHP, you are going to be testing, you are going to be seeing it. For example, you are running a PHP application and you want their PHP regular code, you need to build it to become an image. So when you build it on image, meaning you're going to write a Docker file that will explain how the application is going to be working as a container. Then after you've done that, it does not mean that it's running. So you have to start the container. When you start the container, it's also known as running. That is when the application becomes live. So let me also give you this before we go forward, because we may mistake. We may end up not saying it. Let me do this. Because this Docker is a very complex thing, but the way I'm explaining it, I think it has become so easy for all of us to learn. So now let's put it this way. This is a source code, right? This is a source code. Let's assume this is GitHub or Docker Hub. Now, this is where your developers will work on, right? Developers will do their pull requests and everything. After they have done that, what you do, you now write a file. You write a file, a Docker file. or that file is just a YAML file. You know, most YAML file are management file. They just help you to list steps that you want to do. But just that a YAML file, when you run a YAML file enable you to perform each of the steps one after the other. You understand? That's what most YAML file help you to do. YAML. Just that whenever you put, if you have like 20 instructions you want to run, especially configuration management file, it will help you to list those instructions step by step. So by the time you run it, it will follow this step-by-step process. So that's what the Docker file will help you. It's just like this Docker file is together like this. It will list all the steps that, because whenever a Docker engine see this file here, Docker file, the Docker engine will say, okay, this is my property. This is where my instruction is. So it will listen to that instruction and convert this source code into an image. It becomes an image. Then that image, which means it's already a built application. What is left now is for the application to be consumed. So to be application to be consumed, you can decide you need a compute engine to build it, and you also need a compute engine. This is a source code, SCM, which is something like a storage. Then this is an engine. You need a Docker engine to build a Docker file. You understand me? You need a Docker engine to build a Docker file. But you can decide to test the Docker file after you have built it, because most times it's always advisable to test it so that you know if what the developers plan to do is the same thing as what you saw, like what you order and what you get. Then after they have done that, before this DevOps came into being, this has been the issue, this has been the system deploy, which is mostly done by the operation team. They call them the ops. What they do is that you build this file, just like the way we went to Nginx, that HTML folder, went to the HTML folder in Nginx, and we just put the file inside the Nginx. Let's say HTML folder inside Nginx. You understand? Maybe we are using the Nginx to serve it to the public. So before it was like this. So when the developer finished building, they give it to the operation team. The operation team pack the code and put it in the right directory and expose it to the engine. We call it a compute engine, or it could be a VM, a server, a bare metal, a Kubernetes engine. So what happens is this: what the developer will say their code is running, the operation says their code is not working well. But when there's an issue, they're trying to listen to the application, it's not working well. The developer will say, we did well, we did our work. The operation team will say they didn't do it well. Meanwhile, the fault can either be here or here. That's why the operation team and the development team, they were always having issues. So now this Dockerization is what actually bridge these developers and the operation team together. Why? When the developers finish doing things, they will build it. Some developers know how to build, but the ones that don't know how to build, you as a DevOps engineer, you build it, you show them, they will see it. If it works well, then you now ship it to this deployment. An interesting thing about this stuff is that you can decide, immediately you finish building it, you can decide to save what you have built, meaning a running container. Meaning a container that is running. For example, you build it, you show the developer says, oh, this is what I want. This is what I want. It is what I really want. It's running the way I expected it. Are you getting me? Then what you now do, you now save what is working. It's not like what is going to work. What is already working, you save it into a registry. So if they ask you what's the difference between a registry and a container, a registry and a source code, is the difference. The difference is that a source code is just a code that is being built. So whether it's working or not working, nobody knows. But a registry is already working application, already running application. You understand me? Already running application. That means this application is running, it's live, it's already running. So what is just left is for you to just carry it and deploy. Sorry, not this way. What is left for you is for you to just carry the application and deploy it into your Kubernetes engine or your VM. But you can decide to just build it. After building, you Dockerize. Then after you Dockerize, you take it straight to your engine. So this is called CD. From year to year, it's called CD. Let me put it. Maybe many of us have heard of the word CD, right? From year to year in line, it's called CD. Let me do it again. Sorry. From year to, sorry. From year, excuse me. From year, oh, come on, guy, you do yourself now. Oh, hold on. From year to year. Okay, let me, since this guy is forming stubborn. From year to year, to year. This process is actually called CD. Yeah, you'll be doing well. This is not the time for you to start misbehaving now. Please, a minute. Okay, sorry. So if a system is building from year to year, like you write an automation script that can help developer immediately they commit to code and the code is approved to automatically build, then from building automatically to deliver to the VM, that is called continuous deployment. Meaning as they are committing, is going to the deployment, is going to the engine, continuous deployment. And mostly you do this for dev and QA, because the dev and QA team, they need to know how the application that they are building now is running. So whenever the dev finished, they make corrections, they tell the QA environment, the QA environment is managed by the QA team, while the dev environment is basically by the dev team. Most times developers work across, so that whatever works in QA, in dev, is going to work in QA, you understand? So it's just the same thing that is working. Remember I told you that when you Dockerize an application and you run it and it works successfully, it means that it's going to run, even if you run it 20 times. So you can save it in an artifact. Understand me? But if you don't want you to save it in an artifact, that immediately you finish developing and is immediately you build the code, you write the code, you build the code, you deploy it. That's called continuous deployment. But some cases, you build the code, you write the code, you build the code, then from the code, you build the code, you write the code, and you keep the code. It's called continuous what? Delivery. So you can write a pipeline that can build code. Whenever the developers commit, it will build that code. After building that code, the code will now be kept in a registry. Example of a registry is called JFrog. But we're going to be working with AWS GCRO. Maybe you've heard of ECRO, right? Different cloud provider call it different name. But JFrog is an open source. Then ECRO is for AWS. JFrog, there are more, not like I'm just going to mention one. Like GCP is called GKRO, GCRO. Yes, GCRO. That's GCRO. That's for
Azure calls it ACR.
ACRO.
Azure Container Service.
So they call it different providers have their own different name they call it. But just know that what they are doing is that immediately you finish building the code with a Docker file, then you save it. Then after saving, before you now, from where you saved, you now deliver it to deploy it to the production. So you see this workflow. This workflow is called continuous delivery and continuous deployment, CI/CD. So but from here, it's called CD. This is CI/CD. So this is where the word CI/CD comes from. When you hear CI/CD, when an employer is saying that they need somebody that has CI/CD, you must have CI/CD experience. This is what it means. It's just a different instruction. The same automation tool. One is saying deliver straight as you are building, deliver straight to the deployment engine. Why the other one says as you build, please save it first. Then after saving, before you now deliver it to your engine. This engine could not be, as I mentioned before, that this engine could be Kubernetes, K8s, could be ECS. Maybe you heard of the word ECS, right? ECS is also an engine.
Container service.
Yes, it just run. What it works, ECS just help you to run the container like that. It does not, I think it does orchestration, but the orchestration is 100% managed by AWS. You understand me? Then we also have an open source orchestration tool, also known as Swarm, Docker Swarm. So this ECRO is a sample of a Docker Swarm. Going to help you to manage a Docker. You understand me? But just that this time it's AWS managing it. Why Docker Swarm is the open source. You know, if you don't want to use public cloud, you can use your own Docker Swarm to orchestrate. So we're going to talk about orchestration, but now today we're talking about this. So I want you to know the importance of this, because nobody will help you if you don't know this. You're on your own. But thank God for ChatGPT, it can help you. But if you don't still know it, you don't know it. ChatGPT, another AI tool, will help you make it faster and smart. But if you don't know, you don't know. So if I say what is CI/CD, CI/CD, CI/CD/CD, I mean, this is CD/CD, right? This is CD/CD. CI is taking place inside here, right? So when you say CI, meaning continuous integration, that talks about writing of the code, explaining if the code works, you understand it? Building, this is what we call CI. For example, now this is the CI. Let me use the opportunity to explain CI. So let me do it this way. Hold on. Okay, now let's use this arrow as developers. So developers are making pull requests. You know what I mean by pull request? They are making push and pull requests. They push, different developers are working. Immediately they finish working, they commit to a code, to a code, for example, a particular branch. And when they commit to that branch, you now merge the branch to a single line. You understand? You are integrating what they are doing. Developers are working, you are integrating it. You understand? Branch A, branch B, branch C. Maybe we have a source code, a single branch, maybe master branch is the main branch that everybody is going to be using to work. You understand me? So that is CI/CD. Hold on a minute, please. CI/CD. Yes, CI/CD. Don't see like a very big deal, because sometimes they want to really understand if you know what the concept of CI/CD. CI means CI/CI, CD/CD. Understand me? Continuous development is under CI. Continuous integration is under CI. Then continuous delivery, that means delivery to the registry. Continuous deployment, meaning direct to deployment. Understand me? So Kubernetes, another advantage of Kubernetes can automatically deploy by itself. Because if you do this, and there's a code, there's a script you can run on Kubernetes and say, always do what we call rolling update. Rolling update is an instruction you give to Kubernetes. It's okay. Anytime, in every 20 minutes, in every 1 hour, look out for the source code and see if there's any change in the source code. If there's a change, update the image that you are running. So Kubernetes will continue to update that for you. Call it running updates. ECS also help you do that. So does that. So Kubernetes can also help you to also update to continuous delivery. But this more of it is that whenever you're running a script, a pipeline script. So imagine if you are running this system, meaning you're going to have two pipelines. One is going to be deploying. You run in one pipeline that will deploy. You run one pipeline that will deliver. Meanwhile, in this process, you can also have different applications. For example, from Bitbucket to Docker, you can have SonarQube. The SonarQube, we want to test this code to see if there's an error. Maybe somebody mistakenly leave some code inside, some security code inside or security patches. It does that. Then after this one run, from year to year, you can also have from year to year, you can have what we call JFrog. JFrog, you can also put another source code inside the JFrog to help you to scan the code. Meanwhile, if you are using ECRO have also a code scanning tools that you can also use to scan your artifacts to see if there's an error, there's no error. You understand? That process is what led to DevSecOps. You're just trying to add some security measures across the system. Then this one, DevSecOps, you have to use GPG. Now everybody must not just sign just because you have access to the GitHub. Whenever you want to sign, you must sign in your code using under security application like the GPG or other application to authenticate that the person actually signing into this code is actually part of us. It's just to validate. So that pipeline is actually called CI/CD, but this is a regular DevOps pipeline. That's called DevSecOps pipeline. So, and this being said, shit, we have used the time. Okay, now let's go straight to any question.
I am here. Okay, I have a question.
Okay, go ahead.
All right, so, okay. Now, I have my code in GitHub. Then I built my image. Then do I need to run it as a container before it moves to the registry? Is that the part?
You build your image. The process of building your image, you're already running it as you're already running it as a regular image, right? You tested it in your container before you start the image, but sometimes you may not need to. You don't need to put it in a container. You can just build your image, but you need a Docker engine to build your image for you.
Yes.
But after you have built that image, you can decide to put it in a container. But that image is what you saved here. Because why? You build it in an image, you run it in a container, the container is working. For you to push any code into this image, it must be a successfully built, containerized image. That means for it to be successful, push it here, you must actually have built it with your Docker container, with your Docker engine. So after building it, that thing that is running, that's what you ship, that's what you tag. You understand me? It's what you tag and ship down here. So when you ship it here, it becomes another image. So when you go to Docker Hub, that's why Docker Hub is used to manage this. Another example of this ECR is also Docker Hub. Let me put it here.
Yeah, I wanted to ask if Docker Hub can't work in place of a registry.
The Docker Hub is also an open source, container registry. Most applications that you want to use are default. You could just go to Docker Hub and pull it. Most images are in Docker Hub.
Now, I also have another question. Sorry, you remember that time that I told you that I have a challenge now? Yes. The challenge is actually related to this one, so I really need the clarity. Okay. Now, is it possible to build your Docker file? It is working, you've tested like as a container, it is running, the localhost, HTTP, and the ports are actually running. And then you now try deploying it, let's say to a web app. Is it possible for you not to work in that fast?
Well, if you actually build your document, your Docker, you build it well and it runs successfully, and you want to now push it into another Docker, another container that is different from where you are putting it. If it did not work, it means that your container was not properly configured. But it's not about the Docker now, because that is what DevOps can come to help you to do. To clear the doubt that is not coming from developers. Understand me? Though the doubt that as far as you build it, you test it, it worked in your local system, it means that it's running.
It's working your client.
So if you now push it on that environment and it's not working, it's the operation. Check your ports, check the engine you are using to run that application, check how you're able to push it inside that Docker engine, because whether you are going to run it as a Kubernetes or as an ACS, a Docker system will have to be set up because it requires Docker to run a Docker. You understand me? Or containerization pipeline is already set up. So check it, it's there. So you are not going to go back to developers and start asking them questions. You understand me?
Okay, no worry. Me and you go sit down on top of this particular thing. No worry. Yeah, continue.
Okay, now we have already explained the meaning of continuous CI/CD, right? So you now understand the meaning of CI/CD, right? So I'm going to keep this thing. So in case you hear CD, you're like, it's only one CD they told me now. What is the meaning of CD? Don't be saying a CD is coming from delivery, going to delivery and everything. So when you hear Circle CI, there are some applications that help you to do that automation. It's called, one of them is called Circle CI, the other is called Jenkins. We also have Ango CI, we have Travis CI, all the CIs. So now let's go. We have 30 minutes. Can we use 30 minutes to do something? Yes, let's try. So this is the definition. Docker is a set platform. It's known as platform as a service. So when you hear platform as a service, on that platform as a service, apart from the regular WordPress that I explained last time, right? Docker is also a platform as a service. Docker is a platform for developing, shipping, and running application and everything. This is just a definition for your sake. This one means orchestration, meaning this is Docker, Kubernetes, this is Docker. So we're going to be talking about Kubernetes in our next class, but let's focus on this. Now, there's remember I told you it's an open source, which is an open source, meaning all of us, including me talking, we learned Docker from somewhere. So if you want to learn Docker, you go to their official site. Look at it, docker.com. It's not Docky or Dockeres. You understand? This is it. Come here. This is their official site. This is where everybody that wants to contribute of Docker comes to. So I want to run our first Docker. When you install Docker, right, that time, you will actually run your first Docker if you actually installed your Docker successfully. And you must have a Docker account. So come up and sign up or get started. You must have a Docker account for you to run. I have so many Docker accounts. I can't even count now. Maybe I'll open on that one. So you have to have a Docker account. It's a must. It's a must. Even if you want to run in the Kubernetes engine, you have to have a Docker account. Just like the way you also have you have to have a GitHub account. So unless you want to use the company's account or somebody else's account. So you can come here and create a Docker account, right? I think I have a Docker account. Let me see. I should have a Docker account. Let me see the one I want to use now. See JFrog. JFrog is there. So they are also doing advertisement. They are making money. I think I have a Docker account with this. I don't remember my password now.
Sorry, I wanted to ask. This Docker, how did Docker and GitHub, how did they now make their money? They don't charge anybody for hosting anything.
Docker is a platform. They have enterprise version of Docker.
Because I've been wondering. I mean, I store quite a lot of stuff on GitHub, and I heard you can use GitHub for CI/CD. And I also have quite a lot of images running on my Docker Hub. But there has never been a time they said, okay, or like AWS said, okay, your payment is $100 or $10.
Because you've not really been using it for production. If you're using it for production, there are some things that are not necessary that you have to pay. There are some enterprise version. There's an enterprise version. Everything that you say open source, there's always an enterprise version. You're like Terraform that you're using open source. There's an enterprise version. Enterprise means that you want them to support you. You want to use some extra features that will make your application more interesting. You understand? So because you are not using it, that's why you've not been paying. The day you start using it, bros, you will pay for the subscription.
I don't know why. If I don't enter company, we get money. Company go they pay.
The company pays, but some of them, like, instead of me to pay for that, why not just use the open source or the Docker image? And like, for example, now, you know, most big companies like AWS, like Nginx, most of those source that are not even 100% open source, like mention one big company now. Most of them save their application in Docker. So they pay for security. Because if you are using open source, it's open. So if anything happens to you, you're open to it. But if you use enterprise, you have another layer of security, and they will provide. Sorry, I'm just trying to see if I can log into my GitHub account. I'm trying to reset my account, but it's not sending. As long as I've used this GitHub. Because most time what we just do, you just copy the username and password and be using it for the third-party application. Okay, I think I will just stop. Let me not use this to waste our time. Let's go straight to our class. Let's use the simple Docker file. Use a simple Docker Nginx. Let's go to Nginx and just deploy a simple Nginx at port 8080. So I'm going to just share one script with you, and I will tell you what happened and how that application was used. You understand me? No, we always like to use the word Nginx, right? So let me put this one. Give you this one. Nginx is very easy, one of the most easy web app that we use. So let's put it here. Let me just run it here. Put it here. We'll put this one here. Okay. So you can go ahead and run this script, and I will explain to you what it does. And just run it on your local stuff. It's just a way of introducing you to Docker, right? Because there are other things we're going to be talking. I don't want to make it hard for you first. Let's run the simple Docker application of Nginx. So if I run it on my system, I know that my port 80 may be closed. Have you run it? This time you don't need to install, you don't need to run in, just run that. You don't need to. Let me do something. Excuse me. Let me open my terminal or my VS Code. You know my VS Code, where are you? VS Code.
So yeah, I did. I typed that command now, copied and pasted. So it gave me like more like the image number.
Okay, it means that it's running. Let me put it here. Hold on, let me create in Docker. So I'm going to be this. What we are building now is that there's already a Docker image, right? So we just want to run it. There's already a Docker image. So let me create a file. Let me just say example 1. And this example 1, just run a simple. This is just run a simple Docker. We name Nginx. So now this is, if I run it on my stuff, am I sharing my screen? Can you see my screen? Can you see my screen? No, not yet.
No.
Let me run it. So this is a simple Docker file. I'm running it on my stuff. I know that I may have used that my port 8080, but let me see if it's still open. For the one thing, you cannot serve 2 applications with one port. So you can also serve 2 applications with 1 name. In Docker. Let me see if this is open. You can see it's not running. Okay. Let me run my Docker. You can see it said my engine is not up. So you have to run your engine. I'm running my engine. I'm using Docker desktop. So it takes some time. Is it run now? Is it up now? So you can decide to use, you can even decide to use this one. Docker is starting. You can decide to use here to run all your applications instead of using your terminal. But if you don't want to use the terminal, you can come here. You can come. I think this is the dev environment. Right. Set up, preparing, ready. Enter your repository name. Like I'm going to come here. I think there's an ID that is also part of this. This is my Minikube exited, starting image. So my image, that's all the Docker image I run. Every Docker you run, you have an image set up there. This is my container. This is the only container running. So let's use our VS Code first. So to run, since it's running, I'll just do this. See, it means that that port is open. I've not used this. If I just go to menu of my browser, I will type port localhost 80. You're supposed to tell me welcome to Nginx.
Okay.
So what it means is that this Docker container, you can see, is running at port 80. Because the container itself is port 80 and is binding to my own system port 80. So the container exposed to port 80. So if I want to consume this container, I have to consume it from port 80. So this is the Docker, this is the host. Now let's go to the second one. Assuming I want to run 20 container of Nginx, the same way I'm going to run it, the same way I ran it before, the same way I'm still going to run it. Like now I'm running at port 80 before, right? I think I can expose it to port 81.
Sorry, I wanted to ask a question.
Go ahead.
But don't worry, I've seen the answer. I wanted to ask that which of the 80s is your system and which of them is the base, the original port?
Your system is port. I think your system is port. The first one is your system. Sometimes it can be confusing though. The first one is your system. Wait, excuse me. What is it saying? Conflict NGS. Sorry.
The name.
It's running. It's running. It's running. If I do it again, it will still give me that same error. Let me give this. Let me put this.
No change name.
Run it.
It's already running. It's working now.
This 80 is your system. Why this 80 is the container of the Nginx.
Okay.
The first one is your own. The second one is the container of the Nginx. Now, what I just did now, you may think that first, all these things I did, including the error, that's why it was an error, but the container will still be running. How do you check all your images that you have? You just say Docker image minus A to list all the images. Minus A, ls. It will list all the images. These are all the images. This is the Nginx I ran just now. You can see it's running the latest.
3 months ago, okay.
Meaning I have it in my system before, so it did not download it.
Okay.
If it did not download it, so this is for GCRO 1.8 gig. This is for DevOps. These ones are applications I'm building myself. Understand me? So now let's look at this. Is the image on one, and this is not the container. And this is the container. You say Docker container minus A. So it's supposed to list. Supposed to be minus A now. Supposed to list every container. So this is the container that is there. I'm running to container. Or to just make, if you don't want to be writing Docker container, you just write Docker PS. Docker PS will just list everything for you. So if you say Docker PS, it will list all the things for you. If you say Docker PS, it will list the one that is running. Understand me? But because it's running does not mean that there are no other container inside. So you see that first error that I had? These are the errors that I had. So if you say Docker container, it's only two that is running, right? One is running at port 80, one is running at port 83. But these two crashed because when I was initiating it, it was running on, there was a name already on it. So let me remove it. I think it's Ctrl-C, Docker, container, delete. I can put delete direct or remove. Okay, remove. Let me use RM. Remove this to remove. But the one that is running, you cannot remove it. You have to stop it before you remove. And let's remove the second one. No ROM now, which that's why the reason why we started our class with. You copy the ID, you just say Docker container remove. What did it say? It says it will not remove because it's already running. That means I copy, I copied this one that is running. I copied the one that is running. So let me say clear PS. So if it's running, you cannot move. This is if I say PS, it tell you all the application that is running live. Then if I say Docker PS, we focus on only Docker. Now, say I have two applications running now. Is it two? Yes, 1, 2. One is running at port 80 and port 83. So if I go here, so if you are running this thing in a VM, instead of doing 000, you put the public IP address of the VM and port 80, or the load balance address, the public load balancer, or the, you understand me? So I'm using 000 because this is port 80. This is a local host, my own local host port. You understand me? My local host. This is what that's what I'm saying. But if I'm using a VM, you put the VM public IP address here, because that is where you can access it. So now, if I go to my container, I go to my container, I say localhost port 80 I should have something running there. Then can you imagine now, I'm still going to another container now. I say localhost port what? What's that port? Port 80 what? I think it's port 83. Excuse me. I put port 83. You see on that Nginx. These two Nginx are running consecutively. You can see they are different Nginx. They are different applications. This one can serve a different application, can serve a different application. So I can decide to run another one. It has for you to know the power of what's common, the power of Docker. So if I'm running another one now, let's assume I want to run another one. What I will just do is to change the name. This is the image. This is the name of the image, right? This is the name I want my container to call it, my application. I can change the name here and put the let's say test Nginx, let's say cloud training for enthusiasts Nginx test app. So this is the application that's already been Dockerized before. This one has been Dockerized. This Nginx here you see here has been Dockerized. So what it does is that because I just put Nginx here, it will go to Docker Hub that is public and pull this image inside my system. For example, I want to change it to Docker. Let me run Nginx version 10. So if I don't put any version, it means latest. If I put something in front, it means version 10. This is built by tag. Now, the name of my application. Now, I say Docker run. Docker run is the command to start the engine. What Docker will do, it will create a container and go to Docker Hub and pull this image, because I don't have it in my local system, and put it inside the container and open the container port 83, port 80, which is the default for Nginx. If I put 81 here, I may have issue because when we are building this image, this Nginx, we always build Nginx with port 80 at default, unless we want to change it to port 8080. Then you will now expose it to my own system port 83. So if I run this now, you see, first of all, it's going to go to, he said, what did he say? Docker response demo manifest 10 not found, meaning there's something like Docker Nginx, Nginx Docker version 10. So let's look at for different version. I don't want to say latest. Let's look at for Nginx, different Nginx version. If I put this one now, okay, let's run. I have an issue because the first time it ran, let's remove the Nginx that I have in my local system. Then Docker image ls. Now let's remove this Nginx. You'll see Docker image remove this. What does it do? It said must be forced because why? It's being used. So the container is using it, so we cannot stop.
I think the issue is the port.
No, it's not what I'm trying to run. It will not work because that image is also inside the container. So if you want to remove it, if you remove it, it leads to another issue. Let's look for another the Nginx version. Okay, let's run a simple WordPress. Run.
It's there now. The Docker image you are trying to run is there.
Yes, I wanted to remove it. Let me run a simple WordPress. So what it does is that this Docker will go to WordPress and pull this image running. Let me see if it's going to work. See what is running. See all the container that is pulling. See all the containers that is pulling, all the images that is pulling, because WordPress is actually what? It's a LAMP application, right? So you're going to drag all the LAMP containers. So you're going to drag so many containers together and build it. But what is it telling you? You have, what do you say?
The container is already in use. The name, you didn't change the name.
It's already in use. So
CTFENGNX app.
So you see this challenge, this issue is what Kubernetes helps you to do. Help you to manage it. When you are running it, you will give it a name, so that there will be no conflict. So all this conflict, imagine you want to quickly update a server now. You want to quickly update an application that goes down. Imagine the time it takes me to, because you're going to have human error. But Kubernetes will automatically generate container ID that will not conflict and orchestrate it for you. Let's say container, Docker container, Docker PS. Let me remove PS minus AME. So PS will only just list the Docker that is running. PS minus A will list all the one that crashes. Like this one now.
First one.
Just say Docker container, Docker container. Remove this image ID. Remove, but what did you say? Docker container. Oh. Syntax issue. Okay, it has removed. There. Let's see if it's there. Then how many containers is running now? I can see 3 containers running. 1 mini cube, 2 engineers. Let's run that first one again with the name WordPress. Let me change it to WP. Then let me give it port 686. So you can see, do you notice that it's faster now than the first time? Do you know why? Because that first time it took time to drag the images. But this time, the image is already in my system. It just went to the image and pulled it. Let me see port, my port 80 what? 86, Abi? You can see WordPress. So the LAMP, everything, both the database configuration, it has done everything for me, both Apache. So if I come here now and I say, let's go, WordPress name, password. So this one and the other one, which one would you think is far better for you? If you have to use ROPM, let's say database name, let's say username and password, the database host. What is it telling me now is that despite I've run the database, right? But I've not run, I need to configure the database name. So if I have a database that is running somewhere else, I can put my database name here, my database name, the database name, password, your database username, password, and the database host, which is normally supposed to be localhost. Understand me? Meaning the database have to be running in my system and a prefix. If I do that, it will automatically link both of them together and I'll be working. But for now, only the database WordPress is running, but the database is not yet running.
Why should they always be localhost? Can't I just put my own URL?
It's better for application to be locally accessed, a database to be locally accessed for security purposes. So, if, for example, if this is a VM, my Docker is in another VM, right? I can use it. But since I've already run this as a Docker, it's better you also run your database as a Docker.
There is no necessity.
If I run if I run my database as a Docker, what happened is that because both the container is inside, the Docker is going to be inside the same Docker engine. So it will be easy for my Docker to communicate with themselves, my application to communicate with themselves. So that is why Docker database is always in a local host because of security reasons. That's just one of the best practices. So you can see my WordPress is up, my Nginx is up, and everything is up. So if I want to use Docker Compose, I can decide to use Docker Compose now to do to bind. So in my Compose file, if I'm going to run Docker Compose, my Compose file will now carry both the database configuration, like all this username and password that you answer. I'll put it inside my Compose file. I will run it. Or I can ask my Docker to consume, or my application to consume a secret inside my Docker. Instead of exposing it like this, or putting inside the configuration file, I can deploy a certain file. That file will just have the secret. I will put inside the Docker engine. Will be the one that will just help me to manage both of them. I'll refer to it. So that is something we're going to be talking about much later.
So, sorry. So the Docker Compose is more like a keyboard or a library, right?
No, it's not a keyboard and library. Docker Compose is just like a bridge, just like an instruction that explains how different containers communicate and how they are working together. So a Docker Compose, for example, if I'm running a LAMP application, so my Docker Compose, we have my database, which is my SQL or MariaDB or any other SQL, you understand the database name. Then my PHP parameters, which is running on my front end. Then I'll use my Docker Compose first. Okay. Run this Docker file for PHP, run this Docker file for database, connect this database to this PHP. So the Compose is just to compose them together, to bring them together. That's why it's called Docker Compose. Just an external file that explains how application works and also help you to configure them to function. You can read more about Docker Compose file.
Okay. So that means, no way.
So I think we should stop here. I'm going to give you an assignment. Tomorrow, I'm going to go deeper. But tomorrow, I'm going to explain. You see the example we did now. This WordPress was already built. So we don't know how this WordPress was built. So this one will work. For example, if I'm working with a developer, the developer have already pushed the code into ECRO. I can now, you see, instead of putting this direct stuff here, I'll put the ECRO or GCRO URL here. You understand me? I'll put the GCRO URL here. If I put it here, what it will do is that it will pull the image first into this engine, then build it. So I'll put it here. And that means for that to have happened, my system must have authenticated with my AWS. You understand me? To have access into that ECRO. So you understand? If I want to run an ECRO, or if I want to run a Docker Hub application, I'll just put the Docker Hub application URL image here. So you go to the image and drag it and put it and start. But how do you build the Docker of a WordPress? How do you Dockerize a WordPress? How do you Dockerize a Kubernetes Nginx? How do you Dockerize PHP application? How do you Dockerize Java? That's what we're going to be talking about tomorrow. So that by the time you know how to Dockerize it, then you can know how to start it and how to run it, right? We just did basic running. So tomorrow, please don't miss class. I just pray God give us grace. Please come in time. Do you enjoy this class?
I enjoyed it. But I have plenty of questions.
That is why I'm here. Solomon. Hey, they are ficus.
Those are the efficos of me. I just start to learn.
You know, a fiki. You don't pass fico.
My own na efiki, person we never know anything.